we have found what I believe to be strong evidence that the rocks themselves are sediments that were laid down in liquid water. Opportunity is now parked on what was once the shoreline of a salty sea on Mars.
Once again, there were chemical clues, but they wanted more.
What we went looking for is something that geologists would call crossbeds. If you have a body of liquid water, or if you have air and it's motionless and sediments settle out, they will settle out vertically and they'll settle out to form very flat, uniform horizontal layers. And it's very difficult, if all you've got is flat horizontal layers, to tell what was the fluid in which the sediment settled. Was it water? Was it air? It's hard to tell. But if the fluid is moving, if you have wind, if you have current, if you have motion, then you won't get nice, necessarily flat layers. The layers can become tilted. They can be angled, and they can form what geologists refer to as crossbedding. It's a distinctive thing that you can look at because it gets preserved in the rocks. Crossbedding that's formed in air and crossbedding that's formed in water tend to look in some ways rather different from one another. So what we set out to find was evidence that there was crossbedding of the sort that is formed in liquid water.
So now with that image in mind, what we're going to do is now look at some pictures of the rocks where we'll get to see some of these similar patterns. So here's the first image. This was the PanCam image that drew us to this area that we suspected would be more important to study in detail. So we went in there, and what we see now are that there are basically no parallel lines here. Everything, you can see these expressions of these smiles opening upwards. And in the next slide, we overlay our geological interpretation. The blue lines represent the boundaries between successive ripples that moved past each other. These are the textures that we see in cross-section that we then infer a three-dimensional geometry from. And through the experiments that have been done here on Earth and the natural environments that we can observe here on Earth, we feel very confident that this adds up to a story about ripples moving in water rather than in wind.
A truly significant day in the history of the exploration of Mars. We've talked about water on Mars for decades, and from orbit there's very strong clues or hints that there's water in a few places, but clues and hints and theories and ideas are very different from concrete evidence.
We achieved our objective at Meridiani to go and follow the water and to see if this place could have been habitable in the past. The question we have right now is how long ago was that water there? How long was it on the surface? How deep was it? These kind of questions, how laterally extensive. Some of these we can attack as we drive east towards Endurance Crater, some 750 meters away from where we are right now.
Now Opportunity found smooth sailing over a flat sea of sand. Each new land exploration. Fram Crater had bedrock that looked like Eagle Crater, so sail onwards.
Every time you move, it's a new mission. It's like having a new lander mission every day. You drive a few tens of meters or maybe just turn around and look at things in a different perspective. Obtain a new data set, it's like another landing site in a sense.
Then a stadium-sized crater known as Endurance hove into view. Opportunity had made another.
God, my. No one's ever seen anything like this before.
Okay, we finished. Let's go to the next.
Welcome to Mars, boys and girls.
Today was a very auspicious day. We actually reached the rim of Endurance Crater and we looked down and this is what we saw. And once again, we see that the outcrops of the layered material exist at the top of the rim and absolutely exquisite dune forms on the bottom of this crater.
Mission success!
Opportunity's 90th sol on Mars was a reason to gather the entire team to celebrate.
Very good.
That's wonderful. Where's the entry point?
But there was some worry about a possible plunge into the 20-meter deep crater.
There's a parachute just a few miles away.
Science team is busting at the scene. Feel it in the room when you walk in, the buzz. The only thing is right now we don't know about is, can we get into this crater? Do we want to get into it? If we get in, can we get out?
I think that'll be one of the biggest decisions we make into the mission, because there's always the possibility that you could find a route down there that's gentle enough so that the rover is not at risk, but it's so steep that the rover may never escape again. If the science looks really exciting, that we can. We call that the Thelma and Louise move.
They employed the same strategy